This is the AP Physics B 4-5 video. We're going to be learning about another force, the force of friction. It's another force we investigate when solving Newton's second law problems. The outcome of this video, I want students to be able to recognize and understand where forces are involved in a new equation that we'll be learning today. I also want you to be able to apply the force of friction equation to Newton's second law problems. So our equation is up here. It's the force of friction equals mu times the normal force. The F sub F is the force of friction measured in newtons. The mu is the coefficient of friction, which has no units, and the normal force is measured in newtons as well. So this allows us to find out what the force of friction is. Now the coefficient of friction is something that we're not familiar with. It has a mu symbol here. It looks like a U. It's a combination between the M and the U. It is a number that allows you to compare how slippery two surfaces are. The closer to zero the coefficient of friction becomes, the more slippery the surface will be. The coefficient of friction of a surface can be greater than 1. You will have coefficient of friction with values of 3. So things like that that are very sticky. So if we look back at this equation, we'll see that the force of friction equals mu times the normal force. What that, you can think about it, what that tells you is that the more you press down an object, the larger the normal force becomes. The force of friction will change. The heavier an object is, typically the normal force becomes heavier. And mu also is the determining factor. As mu becomes larger, it becomes more and more sticky, so it's more difficult to pull the object. So those two terms together make up what the force of friction will be. So now we're going to look at 3 different problems and practice solving these problems. The first one is a stuntman is being pulled along a rough road at a constant velocity by a cable attached to a moving truck. The cable is parallel to the ground. The mass of the stuntman is 109 kilograms. The coefficient of kinetic friction between the road and him is 0.87. Find the tension of the cable. The key here is that he is moving at a constant velocity, so we know all the forces adding up on him will add up to 0. I'm first going to draw the picture to give us an idea of what's going on. Okay, and let's draw all the forces that are acting on this person. We have the force of tension this way. We have the force of friction back the other way. We have the force of gravity pulling down. And we have the normal force pushing up. We know that the force of friction and force of tension have to be equal and opposite. They're in the x direction, and they have to add up to 0. We also know that the normal force and the force of gravity have to be equal and opposite as well. So we're going to solve for the force of gravity first. We know that the force of gravity equals mass times gravity. So we take the 109 kilograms and multiply it by 10 meters per second squared. And we end up with a value of 1,090 newtons. We then know that that force of gravity is equal and opposite to the normal force. We can even say now that the normal force is equal to 1,090 newtons. What we're trying to find is the tension in the cable. And the tension in the cable we know is equal and opposite to the force of friction. So if we solve for that force of friction now, we know that force of friction equals the mu times the normal force. And our mu value here is 0.87. Our normal force is 1,090. What that means here is that our force of friction ends up equaling, or having a value of 16.7 newtons. Oh, wait a second, I looked at the wrong problem. It has an answer of 948.3 newtons. So that means since our force of tension is equal and opposite to the force of friction, we can then say the force of tension equals the force of friction, because they have to be equal and opposite. And that ends up equaling 948.3 newtons, and that's our final answer here. Our next problem is a person's trying to judge whether a picture, which has a mass of 1.1 kilograms, is properly positioned by temporarily pressing it against a wall. The pressing force is perpendicular to the wall. The coefficient of static friction between the picture and the wall is 0.66. What is the minimum amount of pressing force that must be used? So I want you to pause the video, draw the picture, and see if you can draw the forces that are acting on this particular picture. We know the pushing force is in against the wall. We know the normal force is out from the surface of the wall. And we know that mg is going to be straight down. And we also know that the force of friction is going to oppose that weight downwards. There has to be a force holding it up, and that happens to be the force of friction. So we know from looking at this, since this object is not moving, all the forces have to add up to 0. The normal force equals the pushing force in the x direction, and the force of friction up equals the force of gravity. I wrote down mg here, which is the same thing. We call it F, force of gravity as well. That is down. So what we want to do is, what we're trying to solve for is the pushing force that we have to hold it with. So that means if we solve for the normal force, we'll be all set. Okay, so let's go ahead, and if we look at the equation, mu equals, we're going to look at the equation force of friction equals mu times the normal force. So if we rearrange this, we end up with the normal force equals force of friction over mu. Now, we also know, we have mu, and we also know from this picture that force of friction has to be equal and opposite to the weight, 10 mg. So we can also write here the normal force equals mg over mu. So let's go ahead and plug in those values. We end up with a normal force equaling mass times gravity. In this case here, it's 1.1 kilograms times 10 meters per second squared. Ends up being 11 all over the mu, which is 0.66, no units, and so our normal force ends up equaling 16.7 newtons, and we have the pushing force then is going to be 16.7 newtons as well. We know those have to be equal and opposite. One thing I want to point out in this problem is the coefficient of static friction is discussed when the object is not moving. And in the previous problem, when we had the stuntman sliding along the ground, that was a coefficient of kinetic friction. Kinetic means it's moving, static means it's not. The coefficient of static friction is always a larger value than kinetic friction, just because it's more difficult to get something to start moving. Okay, let's go on to our last example. This is a coefficient of static friction problem. A 2 kilogram block is placed on a 30-degree incline. What must be the minimum coefficient of friction between the block and the incline in order for the block to not slide down the incline? So let's go ahead. I want everybody to pause the video, draw the picture, see if they can draw what the forces are, and we'll go from there. So everyone go ahead and pause this video. Okay, here's our block on the incline, and we have the force of gravity straight down. And we have the normal force up like this. And we have another force that we haven't drawn yet. It's the force of friction up the incline, stopping it from sliding down the incline. Now remember, we have to break that force of gravity up into its xy components. We have to tilt our xy axis like this and break that force of gravity up into its xy components. So we have it here, and here is our two components, and this is our angle right here. It's a 30-degree angle. And what we're going to do is solve for our force of gravity. We know it's mass times gravity, so we have 2 kilograms times 10, so our force of gravity is 20 newtons. Then we do sine and cosine of the two sides of the triangle, and we find out that the opposite side ends up being 10 newtons. And the back side here is 17.3 newtons. What this means, looking at this picture, since the forces in the x direction have to add up to 0 and the forces in the y direction have to add up to 0 because this object is not moving, is we have to say normal force. We can say right now normal force equals 17.3 newtons. We can also say the force of friction equals 10 newtons. just from this drawing. And what we have here is we can go ahead and solve for mu phi force of friction all over the normal force. Now our force of friction in this case is, we just solve for, is 10 newtons. My normal force is 17.3 newtons. And so my coefficient of friction ends up equaling 0.58. Every problem we've done today is with static equilibrium. The object is not moving, or it's dynamic equilibrium in the case of the sliding stuntman. But in every case, all the forces add up to 0. In the next class, in the next video, we're going to do problems where all the forces do not add up to 0. We have all sorts of forces, whether it's friction or tension or whatever. They're all going to add up to something besides 0. So anyway, this is practice for using the force of friction and recognizing how to use this equation.